good. We'll move on to Holomem and Charlie Gale, who joins us from Germany, but you're not normally in Germany, are you, Charlie?
No, normally in London. So yeah, good day to everyone. I'm Charlie, founder of Holomem, and delighted to be with you here today.
Okay, well, take it away. The next 35 minutes is all yours. So hopefully we'll have a little presentation from you, and then Michael will dig into some questions as well. So if you've got questions for Charlie as we go along, please do pop them in the chat box, and we'll feed those in. So yeah, over to you, Charlie.
Fantastic. And can everyone see my screen?
Yes.
Wonderful. Well, as I said, yes, Charlie Gale, founder of Holomem. I'm an engineer by background, and I'm here today to tell you how Holomem is approaching one of the biggest challenges in digital preservation: how to store growing volumes of data reliably, affordably, and sustainably over the long term. As I'm sure this group is well aware, original data creation is growing exponentially. And in fact, over the next decade, we're projected to do a 12x of the amount of total data in the global data sphere. This amount of data and the required storage to go with it is putting a huge strain on the global ecosystem and pushing existing tiers of storage right to their limits. What's more, in an industry that already has a larger carbon footprint than global aviation, most of this data actually becomes cold quite quickly, yet we still need to store it safely for decades. Of the existing storage tiers, we have flash data storage, hard disk drives, but ultimately magnetic tape. Users are being forced to migrate their data sets further down the tiers in order to kind of serve better costs and have a more sustainable output over their data storage. That's where magnetic tape really comes in. And this audience will understand that the stakes here are particularly high, whether it's preserving cultural heritage documentation, ensuring scientific reproducibility, or meeting regulatory requirements. There is a growing need for long-term, low-cost, and highly robust data storage solutions. The best existing solution here is LTO magnetic tape, the beloved workhorse of high capacity and cold storage. It's the cheapest solution out there, offering the lowest total cost of ownership and upfront costs. But consolidation in the market means that customers are at the whim of just a few suppliers. IBM, who are currently the only drive suppliers for LTO magnetic tape, just increased their drive prices by over 30%, not due to any supply chain challenges, simply because they can. There's enough demand for the technology. You would have heard again and again that tape is dead, but actually it still remains in a class of its own as this beloved workhorse of high capacity storage. However, it's not able to keep pace with our increasing capacity and robustness demands. There are concerns about tape's stability in archive, with data rot being a big theme. And I recently heard data rot being likened to checking if your red wine has been corked. By the time that you find out, it's often too late. And when these cartridges are being stored, they have to be kept in quite controlled environmental conditions. And when they go outside of these conditions for temperature and humidity, the data rot of the cartridges can increase. Lastly, the latest tier of tape, LTO10, was announced recently. It was a delayed launch, and they launched with a lower cartridge capacity than was originally advertised. So there's a growing need to continue to do more with less. At Holomem, we have been developing a future-fit cold data storage solution designed for deep archive use cases, where longevity, cost efficiency, and sustainability are paramount. Holomem is actually a riff on holographic memory. So we're looking to do a multi-layer optical data storage platform where we record data as micro holograms within the body of a thin polymer film. So that image you can see on the right-hand side there, that is our holographic media. We were founded in 2020 as a team of hardware junkies based in London, bringing together skills in photonics, mechatronics, and mechanical engineering to build a fully integrated archival storage system that we view as a superseder to the LTO format. We call it the HoloDrive. Our HoloDrive technology uses lasers to record these micro holograms, locking data in polymer chains to form a highly robust long-term data storage technique. The benefits of using holographic storage over existing magnetic tape is clear. Our media is a very low cost and robust film that is currently already used in various industrial applications and has been optimized and democratized actually by the automotive industry. So they laminate this same film into car windscreens for head-up displays. Other people have done the hard work of making this a very robust and low-cost film. Crucially, we've engineered our media cartridges around the LTO format, meaning that they are plug and play with existing tape storage libraries, like on the previous slide, a low friction approach. We're not here to replace existing tape systems, we're here to complement them. The HoloDrive is presented as the deepest archival layer, where data is rarely accessed but must be preserved reliably. It's a write once worm drive optimized for long-term immutable data storage. Having announced our first working fully integrated system in late 2024, we've been actively socializing the HoloDrive and its attributes with the industry to get feedback. Here, it's been really nice to hear that it resonates with some clear benefits to the archival community, including the long media lifespan and no energy consumption during storage. You can store our cartridges in any ambient conditions with no AC required. Crucially, we've been building the media and the drive around a fully scalable architecture. Our plug-and-play cartridges are using low-cost components and media, and the HoloDrive itself is also assembled using off-the-shelf, low-cost components. It's a commercially viable solution presented as a product, not a project. Since announcing the first HoloDrive some 15 months ago now, we've been working to further refine our system. So the image on the left was actually our first partnership. We're in partnership with BDT. BDT are the world's largest tape library manufacturer, and we've been working with them to integrate the HoloDrive within their products and their platforms as an alternative to LTO tape, demonstrating our plug-and-play compatibility. This also allows hybrid operations of tape libraries where you can have LTO running alongside the Holomem system, offering an additional tier of deep archive, high-capacity media. The image on the right was actually our first pilot, so we were delighted to say that we've completed our first fully integrated pilot installation late last year, installed in a UK-based data center, demonstrating the full stack of our full integrated system working together. The first holographic system that's ever made it to a data center. Following this first pilot, we're now developing several systems in our lab, which will be deploying to operational environments this year, with a view to building out our use cases and identifying our first customers. As we stand here today, the team back in London is working to develop our first commercially available HoloDrive, which will launch in early 2028. The system will be competitive with LTO in cartridge capacity, but offer lower cost media and a longer term, more robust data storage solution. We're also able to offer two key benefits over LTO. Number one, our drives and our media will always be backwards compatible. It's a huge challenge for existing operators when new cartridge capacities are announced that you also have to upgrade your drives to go with it. We will always have backwards compatible drives, meaning that we're dramatically reducing that upfront capex cost. We're also able to execute a read-only HoloDrive system. So whereas existing drives are both write and read, we can do a write and read drive and also a read-only drive, which we'd be able to present at a much lower cost, which of course is highly relevant for our archivists. I'd say that in lessons learned, for us, it's hardware is hard. It's been a very long journey for us to get to this position, to have a stable, reliable system that we can work with. And we also have to be aware that whilst this is a new technology that we are confident presents some new capabilities, we are working in a rightfully very conservative marketplace. In an industry where no one gets fired for hiring IBM, in our case, it's literal. we are the new kids on the block. But we are here, and we've designed the Holomem cartridge and HoloDrive to be a future fit, long-term data storage platform. And I'd love to explore how we can collaborate with the DPC community. Thank you, and I'd be happy to take any of your questions.
Well, thanks for that, Charlie. People have anticipated what I was going to ask, which is to give you a quick round of applause, especially, as I say, having jetted in God knows what time to Berlin and get to your hotel and doing this from your room. That's fantastic. So does anybody have any sort of immediate responses or questions they'd like to put to Charlie? Giving you a second to type. Okay. Well, perhaps whilst people are thinking, I'll weigh in with a couple that occurred to me. I'm sorry if you said this, Charlie, but do you have a sense? Have you done any tests for sort of? You talked about the sort of lifespan of current LTO tape, and how long it is before you have to refresh it, and so on. So, can you say what it might be for Holomem? Are you talking years, decades, centuries?
Of course. No, we're actually we have the benefit that our media, having been produced for other applications, is already guaranteed by the supplier for a 50-year life. That's in an automotive application where their biggest fear is UV degradation of the material in a car windscreen. So we're very confident that we can achieve multi-decade life, possibly century and beyond.
And I guess that's sort of in environmental conditions. So the technology, I'm assuming from the name, is basically optical, is it? So it's it's holographic writing to the tape.
Yes, yeah? Multi-layer optical storage. So in another life, I founded a business that was making machine-readable holograms as security labels. So we put a multi-layer QR code in a label, and that multi-layer machine-readable data set is, I guess, the core skill set of the team that then went on to form Holomem. So it's optical multi-layer storage.
So I'm guessing then for things like EMP radiation and stuff like that, that some people worry about, you're fine. What have you done tests around sort of like heat and things like that, or doesn't that come into it?
Absolutely. I mean, we kind of refer to our media as kind of the cockroach of data storage media, right? It's a very, very robust polymer. And one of the first things we did in the lab back in 2021 is we recorded the album Random Access Memories by Daft Punk onto a 1-inch piece of our film. I took that piece of film home and cooked it in the oven with my dinner that night, and we brought it back in the next day and replayed the album. So we've always known that we've got a very robust material for temperature, humidity, of course, EMP proof. So yeah, it's here, and I think for long-term archive, where of course the maintenance of that facility and the energy overheads with kind of providing that stable environment is a huge consideration. Whereas we're saying you can run this long-term storage at totally ambient conditions wherever you are.
Okay. And again, sorry if you touched on this, but perhaps to unpick it a little bit, do you use any sort of either well-known or proprietary sort of compression algorithms to try and squeeze as much information as you can on a tape, or do you go the other way and sort of say, actually, we want to keep it as open and easily readable as possible, even if that takes up more tape, it's worth it in the long term to make it more accessible and avoid any of those sort of hardware or proprietary solutions?
No, it's a really good question. And as we stand, we are the open, accessible end of the scale. We're fortunate that actually to achieve high cartridge capacities, there's so much kind of additional space left in our media, as it were. So we want to present our cartridges as kind of an open format where the reading of this data in multiple decades time would be possible, right? This is we're talking about multi-decade storage where the HoloDrive system that was there to write that data might not be there to read that data in the future. So it's very important that these things can be accessed in the future.
Okay. And I guess the sort of the advertised strand for all of this is sort of procurement and procuring systems. So reading into what some of the examples you were saying there, so it is your kind of, I guess, target market, is it mainly the sort of the big data centers, the big system providers, rather than kind of the end user? You're just saying, well, I'll let you speak for yourself. I shouldn't anticipate. Go on.
Well, I mean, there's certainly undeniably the hyperscalers are huge users of tape. They often don't call it tape. You have like AWS Glacier, for example, it's just tape libraries that they're using as that ultimate tier, low cost cold data storage tier. For us, that's a very relevant part of the conversation, but they're also going to be probably the hardest nut to crack, as it were, when it gets to adopting new novel technologies. So for us actually to engage with the high performance computes and kind of specialist archival communities is going to be a far earlier conversation that we can look to have. So the pilots we're doing this year are with some archives and with some high performance compute users. We've found that these users have the appetite and the agency to engage with new novel technologies. And when we've been presenting it in this plug and play, low friction format where your existing tape libraries, your existing infrastructure that you put around magnetic tape can work with the HoloDrive, it's a very easy for them to trial and adopt with us.
Okay. And I think you were sort of tangentially touching on some of the, so in terms of the kinds of data you think your your approach is particularly well suited for, I'm guessing, is it things like I don't know, the movie industry, really high value, very large files would be one for you, or perhaps legal information or medical information that you kind of think, okay, we want to prove that this is written once, not changed, preserved for a very, very long time. Is that the sort of scenario you're after?
Correct. So yeah, I mean, we are unapologetically worm. We are immutable at a media level. So write once data. When you're looking at long-term archive, either from desire or through regulation, which is also part of this, that's where we will really come into play. Of course, existing LTO tape is rewritable. So for backup use cases and kind of more kind of refreshing of media and cartridges, that will always be a superior technology. I think that's why positioning Holomem as an additional tier of deep archive for things like the media and entertainment industry, medical records, is where this is a companion product that offers additional benefits.
Okay. And do you see people, or do you, I can imagine, yes, your tape sitting in, a standard tape library, say the drives fit in there. Is that very much the sector you're going for? Or are you saying, oh no, people can, you can return these tapes potentially to customers, and if they want to stick them in a salt mine or in Svalbard or whatever it is, that that's not going to be an issue? Or is that not really what you're aiming for?
No, I think we're aiming for both. I think, yeah, certainly presenting this as a totally plug and play within existing libraries, existing environments is a big part of this. But I think there are additional use cases that can be unlocked by this very robust media. You even look at kind of the oil and gas industry and kind of various research groups that are currently using LTO in very difficult conditions, and the considerations they have to bring in order to ensure that the cartridges are safe it is a big consideration for them. So we're here with a more robust alternative that is better suited for those kind of very extreme environment conditions.
Okie doke. And you also described in your opening that sort of you're a relatively new business, you're growing, etc. So am I speaking out of turn if I say you're happy to talk to anyone? You're willing to explore ideas and invest things, or have you got a sort of a kind of a product roadmap in mind, and people should watch this space and see what's coming?
No, absolutely. I mean, I think now that we have done our first live deployment and the HoloDrive is live, as it were, we're actually incredibly keen to get it out there. For us, we have dozens of prototype systems we're pulling together now within various tape library formats. And we're really keen to put those into as many operational environments as possible. So I think my ask of the community here, I think this is the perfect world for us to be presenting that the HoloDrive is here. Would be delighted to have conversations about where we could install it, what use cases we could cater for, and how that speaks to this community.
And are you able to offer site reference visit? Can people go and, if necessary, go and see what BDT have done with it, or is that kind of all super secret? And
no, not at all. I think we're going to be going to multiple conferences this year with our integrated system with the BDT library, so you'll be sure to see it at various conferences. But I'd also say if anyone would like to know more, please feel free to reach out. We can really go through the details, and it goes without saying our lab in West London is a fun environment for anyone to come and see the technology firsthand. We have full systems running within tape libraries, and we have our development lab where there's lots of lasers and fun things going on. So we'd be delighted to show anyone around.
Okay, well, thanks, Charlie. I'm going to follow Sarah's earlier example. Say, if you're awake enough still to put your contact information in the chat, so if people want to get in touch, obviously you can Google Holomem or use another search engine and find your site to follow up and look out for you, I guess, at the conferences and stuff that are coming up.
Absolutely. Thank you all so much.
Thanks, Charlie.